Hi students, my name is Sumalata. In today's class, I am going to teach you about cis-trans nomenclature or EZ nomenclature. How can you identify the particular isomer is having cis-trans, the particular isomer is having EZ configuration. Okay, before watching this one, you should have an idea about RS nomenclature as well as what is stereogenic center, what is the chiral center. Then after you can watch this, you will get clear idea. Okay, now coming to our topic students, cis trans or EZ nomenclature or EZ configuration, which molecules or which isomers are going to show cis trans nomenclature or cis trans isomerism. See, properly substituted olefins are cyclic compounds can able to show cis trans isomerism. Here you can take one example. This is an olefin students, it is hydrogen, this is methyl group, it is hydrogen, and this one also methyl group. Here on double bond, the similar groups present in same side, that is the cis isomer. If the similar groups present opposite side, so that is the trans isomer. By seeing this, you can tell one thing, that means both ends having at least one similar group or atom, then only you can able to identify cis trans isomerism. Okay, you can take one cyclic compound students, it is the double bond, it is phenyl group, it is also phenyl group, it is hydrogen, and this one is the hydrogen students. See, this phenyl is the ring molecule. Okay, so here the two groups same side, so that you can directly write this is the cis one. If the two groups are the opposite side to this double bond, that is the trans isomer. What is the name of this compound? This is the stilbene students, stilbene. This is the cis stilbene and this one is the trans stilbene. These two isomers are identified by UV spectrometry. Okay, now you can take one more example, but2-ene dioic acid, COOH. This one also COOH, this one is hydrogen, this one is the hydrogen. This is the cis form of but2-ene dioic acid, and you can take trans form of but2-ene dioic acid, COOH, COOH. This is the hydrogen and this one is the hydrogen students. It is the trans form. So what is the name of this cis form of but2-ene dioic acid, and what is the name of trans form of but2-ene dioic acid? This cis form is known as malic acid. Okay, this trans form is not the trans malic acid. Okay, this trans form is the fumaric acid. Okay, now you can take one more example here. If any one end have similar groups, at that time is it possible to identify the isomer is having cis configuration or another isomer is having trans configuration? See, this type of molecules you can't able to identify cis trans nomenclature or cis trans isomerism. Why? Because what is the rule here? Two ends are having at least one similar group, but not one end have similar groups. Okay, here this end have two similar atoms, so that it's not possible. And one more condition is, see here, this is one olefin, it is attaches with A, B, C, D students, all are four different groups. At this time, is it possible to identify cis trans isomerism? See, to this type of molecules you can take reference groups or reference atoms. Okay, then only you can tell cis isomer or a trans isomer. Here I am going to take A and C are the reference groups. If the reference groups are opposite to each other, that is the trans one. If the reference groups are same side to the double bond, that is the cis isomer. So here it is the trans isomer. Okay, opposite, if you can take these reference groups in same side, that is the cis isomer. But this is not the convenient way to identify um, molecules are having cis isomerism. The another isomer is the trans one, because at the time of four different groups, if the double bond is attaches with four different groups, this is not the convenient way. At that time we are going to use E and Z nomenclature, or E and Z configuration. uh, so that here we can call it as a E and Z configuration, or E and Z nomenclature is the alternative way instead of a cis trans isomerism or a cis trans nomenclature. Now we are going to discuss about what is EZ nomenclature. Here also olefin students, to this one, see, what is what do you mean by E, what do you mean by Z? E is nothing but antagon, that means across. Okay, Z means jisman, that means together. Okay, see, on olefin you can take simple olefin here. This is bromine and this one also bromine, this is hydrogen and this one is the hydrogen. On double bond, I mean both ends on double bond, you can give priority to that groups attaches to these two ends based on RS configuration or RS nomenclature. Okay, see here, at this end bromine and hydrogen are there, at this end also bromine and hydrogen are there. So here according to RS rules, what is that one? Higher atomic mass or higher molecular mass will get first preference, lower atomic mass or lower molecular mass gets a second preference. So here bromine gets the first preference because it is having higher atomic mass. Hydrogen gets the second preference. Here also bromine gets first, hydrogen gets the second preference. So after giving priority to these groups attached to these both ends, you can go, if the similar numbered groups are similar priority groups present in same side, that is nothing but Z configuration. That means this isomer is the Z isomer. Okay, coming to next one, you can take bromine hydrogen, this is hydrogen and bromine. After that also you can give numbering here. This is first preferred group, second, this is the second preferred group, this is the first preferred group. Here the similar numbering groups, numbered groups present across with each other are opposite to this double bond, so that here it is the uh, E configuration. That means this molecule or this isomer have E configuration, that isomer have Z isomer. See, I mean Z configuration. Here also by seeing this molecule you can easily tell which one is cis and which one is trans. The first one is cis one, the second one is the trans one. But one more thing you can remember, all cis are not Z, all trans are not E. Okay, that will depends upon only the preferred groups only, not cis become Z and trans become E. Okay, now up to this extent, okay, this is the simple olefin having one double bond. If more than one double bond is there, at that time what you have to do? Okay, see, it is the molecule or isomer having two double bonds. This is methyl group and this is hydrogen. This is also methyl group students and this one is the hydrogen. Here it is hydrogen. It is hydrogen, or you can give another group also, or another atom. See here, based upon RS configuration rules, you can apply. Here it is the first preferred group. This is the second preferred group to this carbon atom. To this carbon atom, this is the carbon and that one is the hydrogen. So it is the first preferred group. This is the second preferred group to this end of this double bond. So here the first preferred are similar numbered groups present opposite across with each other, so that it is the E isomer. Coming to next one, it is the carbon, students. Here it one gets first number, it one gets a second number, and this one gets first second number, and this one gets a first number. This is carbon and this is the hydrogen, students. So here also, see, the first numbered, first preferred are similar numbered groups on same side. So it is the Z isomer. It is the Z isomer. Here also you can apply cis strands also. Here see, this is carbon and this one also carbon. Here it is hydrogen and it is hydrogen. You can take these two hydrogens as a reference. These two groups are present same side, so that it is the cis isomer, cis configuration. Here hydrogens are in opposite side, so it is the trans configuration. See, students, after that, by seeing this molecule, how many isomers are possible for this molecule? If you want to know that one, you have to use this formula, that is 2 power n. Okay, here see, it is the 2 power n. N is nothing but number of non-identical double bonds. Okay, number of non-identical double bonds. So here in this isomer, how many double bonds are there? 2 double bonds. So that you will get the value is 4. That means 4 isomers are possible for this molecule. Those isomers are nothing but E, 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 Z. Next one is Z, Z. Another one is ZE. These are the 4 isomer, students. To get that one, see here you can exchange these two groups. Okay, at that time you will get one isomer. After that you can exchange these two groups. At that time you will get one more isomer. Here you can exchange position of, you can flip this molecule. At that time one more isomer. Then you will get 4 isomers. Okay, after that, if any molecule having double bond as well as chiral center, at that time how can you identify Z configuration, E configuration? Okay, see, you can take same molecule, instead of this second double bond you can attach one chiral center. This is the carbon, students. It is attaches with amino group. This is NH2 group. This is methyl. This is hydrogen, students. So it is the chiral center. It is attaches with 4 different groups: NH2, CH3, hydrogen, and this one is the olefin. So here, how can you identify number of isomers for this type of molecules? Double bond along with the chiral center. At that time, this formula will become number of n is equal to number of non-identical double bonds along with the number of chiral centers. Okay, so here you can see one double bond along with one chiral center, so that n is equal to 1 plus 1 is equal to 2, so that 2 power 2 is equal to, here also 4 isomers, students. Here to this chiral center you can go to apply RS configuration. See, this nitrogen gets first preference. Okay, next one is this second, this is the third, and this one is the fourth. So This is in clockwise, so it is a R configuration. See, here you can write ER. This molecule is the ER configuration. After that, you can exchange positions to get remaining isomers of this molecule. Okay, this is about cis trans or EZ configuration, students. If you have any doubts, you can post in comment box. Don't forget to subscribe, don't forget to like and share these videos to other students. That makes me more energy to make more videos. uh, Take care, students. Bye, all of you.